What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
Welcome to another episode of the Concrete Logic Podcast, and today I have Darren Baldwin. He's president of PIKUS. They're a 3D concrete products company headquartered in Utah, and we're going to talk about analog versus digital concrete formwork. And you're probably like, what the heck is that? Well, Darren's going to tell you what that is here in a second, so hang on. But before we get started, I just wanted to remind you how to support the podcast. If you're listening to this and you haven't done one of these three things, you need to do it after you hear your options. So the first thing you can do is, if you enjoyed today's episode or any of the episodes you listen to, you need to share the podcast with a colleague or a coworker. The next thing you can do is, if you go, we have a website, www.concretelogicpodcast.com, and in the top right-hand corner, I'm looking at it right now, there's a blue button. It says donate. If you click on that, you can donate to the show. And then when you donate to the show, not only do you support the show, which I greatly appreciate any amount that you send, I will share that you supported the show. So if you've heard the last couple episodes, I've shared who's donated to the show. So you could hear your name on the podcast, become concrete famous. And then the third thing you can do is on the same homepage, there's a little microphone in the bottom right-hand corner. You can click on that. And if you listen to the Dan Baker episode, that was a couple episodes ago, you would have heard a voicemail from a listener who was asking to interview Dan Baker. So that's how that happened. He went there and clicked on that microphone, left me a voicemail and said, I want to hear from Dan Baker. Granted, it took me a year and a half to make that happen, but dang it, I made it happen. So there you go. And then if you like the format that we do for the podcast, as far as, I bring folks like Darren in and we talk about a topic and educate you on a topic. If you like that format and you're an engineer and you need to get professional development hours, we do have a way for you to do that through the concretelogicacademy.com. So check that out as well. All right. That's enough selling today for me, Darren. So we're going to talk about analog versus digital formwork. What the heck does that mean?
Very simply, Seth, analog versus digital formwork. We're used to analog, right? Boards and aluminum forms, and we handle those with our hands, and it's real and it's tangible and it's analog. Digital formwork, though, is very different in that it exists in ones and zeros. Imagine your 3D model, right? That's your digital formwork. Much more fluid. You can save a digital formwork if you get a custom, say you get a custom concrete item done and then someone crashes into it. Like we had here in Lake Eola in Florida, we had a race and a truck backed into a unique concrete piece, Seth, and they called us 2 years later after they were at install and they said, hey, do you still have that form? The answer is yes, because it was digital. It's a digital form. So we just hit print 2 years later. And we send them the item, custom, unique piece.
Wow.
That's the difference.
From the time they called you to the time you delivered, how long was that, Darren?
First time around, 5 weeks. You're talking about when the piece broke 2 years later?
Yeah.
Yeah, in a matter of weeks.
Yeah, that's cool.
Mm-hmm. Yeah. Yeah, it's easier to store, easier to move, and easier to change. Digital formwork, it is.
Yeah.
So, and that's why, architects are waking up to the benefits of digital formwork versus analog. It's the ability to control the design, to achieve a design and a curve or a uniqueness about something they're looking to achieve.
Right. So we're talking about 3D printing.
Well, yes, in this case, that's how we use digital formwork. There's probably other ways to do it. I've seen other ways, whether it's extruding via print nozzle, right? That's how we do it in Salt Lake City. And it could be done in other ways, but that's one of the primary ways it's done in concrete these days is through 3D concrete printing.
So how do you explain this to architects? And when do you use this versus when it doesn't make sense to use it?
Yeah, that comes down to economics, Seth. And today we are very competitive when it comes to unique designs. So when we talk with architects, we say, hey, if it's unique and it's organic, 3D concrete print's the way to go. If it's highly repeatable and nothing is changing about the design and shape, maybe precast makes sense. And obviously cast in place makes a lot of sense for structures and reinforcing, so structural. But where you don't require structural reinforcement and it's highly unique, that's where 3D concrete print can play a role in fitting that need. And so we're finding use cases in interiors, in mostly landscapes, all being architectural concrete.
So can you talk about some of the limitations with what we're calling analog formwork versus what you can do with digital?
Yeah. So when you think of concrete, right, we're used to analog formwork and we're used to repeatability of that formwork. We use that formwork over and over. With digital, it's true that you can use the same digital file, the 3D model, over and over. But one of the advantages is you can make changes and adjustments. We have a project right now where we're finishing 2,000 linear feet of non-repeatable seat wall that all has integrated LED lighting. And it is morphing and changing from plan view and from elevation view the whole time. So it's tapering and curving, diving and moving up and down, left and right. What's also happening, Seth, is it's doing all of this on top of grade changes. So it's not on a flat plane. Now, when you're doing precast, it sure is nice to have a flat plane because you want to have a form and you want to repeat it over and over. If you use that form and you go from a 3% grade to a 2% grade to a 1.5% grade and then to a 1, back up to a 4% grade for ADA reasons, right? In theory, your fitment's going to be off or you have to come up with new forms. With 3D concrete print, we make those adjustments in the file to follow the grade as it moves and flows, all while keeping vertical lines at our seams. That's the advantage of digital formwork in that particular use case.
Gotcha. So this is, I think we said it, but this is your best use case is architectural concrete. So when I think of architectural concrete, I mean, it comes in a number of different forms. So it could be just the finish. So we can use a standard formwork and we can rub it and patch it and make it nice and shiny as best as we can. And then there's I've done self-consolidating concrete, which then you need special formwork to handle the pressures of that. So those are, I guess I'm naming some limitations there for the cast in place version. Are there any limitations to doing it with 3D print or what we're calling digital version?
Certainly one of the limitations is going to be know-how and understanding of how to change the digits, right, on the design side. So it's a heavier design lift. Design and engineering can all be done digitally. So we're doing full destructive testing. But the limitation is, right, on destructive testing, you could do FEA analysis on almost any kind of structural concrete these days because there's plenty of data available. We're having to do full-size destructive testing because the data from a structural engineer's perspective is not available. And so that would be one of our limitations. Is under a structural use case, I don't think anyone in the world hardly has the data for what's going to happen. And so we've had to, build in that timeline. For example, if someone came to me today and said, I need to retain 48 inches of soil behind a planter wall. If someone came to you, Seth, there's plenty of use cases for managing 48 inches of soil, right? For structurally reinforced concrete. For 3D concrete print, though, not as much data out there. So that certainly would be a situation where digital would be limited.
Right. So you're not taking test cylinders of your product?
Oh, I didn't say that. No, we are. We do crush tests every day. So every day we take 2 by 2 cubes and we crush those.
Like grout cubes?
Yeah,
okay.
Exactly like a grout test.
I gotcha. Then when you say, what'd you call it? The destruction test? What'd you call that?
Yeah, we do a full size print of a maybe a typical cross section, and then we would bring it to destruction. So under a soil loading situation, we might build a frame. A sideways frame is how we built and tested this previously, and we loaded up with sandbags and let it set over the weekend and see how it performed. And in some cases, we'll load it up to the point of destruction and just see what's the full mass that it can handle all at one time.
Huh.
Mm-hmm.
But you've been doing this for a while, so you probably, do you have to do this every single time, or you got?
You are right in that after you have tested certain cross sections and certain geometries, you begin to be aware of the kind of loads it can handle and manage.
Yeah. And the engineers and the architects, they're accepting your data without any pushback. They just say, hey, Darren's a good guy. We trust him.
Well, you are right. Under International Building Code, anything over 48 inches would have to have an engineer stamp, right?
Uh-huh.
Under 48 inches is the discretion of the owner, right? So we have brought in our engineers and can get stamps based off of the data that we are collecting under their counsel. So yeah, that would come down to the specific structural engineers' tolerance for risk and how much testing they want to do. But we can certainly under every project provide an engineer stamp if necessary.
Yeah. So percentage wise, the products that you're making, are they more structural or architectural? What's the split there?
Yeah, we don't do anything today that anyone would call structural, although we all know that everything has some amount of structure that it needs to manage. When I say structural in general, for example, if there was a stadium project, we would never look at doing anything that would hold up stadium seats, although we might consider doing the bench tops, and we have done that for a stadium. And so it's even the structure of the seat itself. We do BIFMA testing, which is recognition of, there's a standard in North America for the amount of the size of a sandbag that we drop from 6 inches above the bench and see how it handles that kind of abuse. And so there are some structural load requirements for seating, but for the most part, you're right. We are sticking to what is considered site work and what would be considered site furnishings, maybe some facade walls on an interior. We've done some of those in an aquarium. So more and more use cases are accumulating. In some cases, we got asked to do a 12-foot large fire pit at a stadium. And because it was such lightweight, because we're printing hollow, we were able to delete the stem wall because this was going to be cast in place. And as a result, it simplified the construction schedule for the GC, as they didn't have to navigate stem wall and gas line, right? They could just stub up the gas line on the site work slab and then set this hollow fire pit that's 3D printed in concrete over top of the gas line.
That makes sense. We did an episode back in, we were trying to figure out the time, but near the end of 2023, episode 71, and we discussed, I told you back then, I'm skeptical of 3D printing, and I asked you to come on the show and convince me otherwise, and you came on, you did a great job. You said, hey, this is our use case. So essentially you're precasting or printing products in a warehouse just to catch everybody up. I did a bad job. We were We were assuming everyone listened to that episode. So that's what PIKUS does. They print them in a warehouse and then ship it everywhere in the United States. Are you shipping beyond that now? Not yet?
We have an opportunity in Los Cabos, Mexico. So if that comes up, Seth, I'll probably ask you to come down and help out with that.
Okay. Sounds
But
good.
mostly no, in the United States.
Yeah. And I thought that was a very unique way of using 3D printing versus what we've been seeing out there in the world. So again, getting back to the analog versus digital. So I kind of helped you. I teed it up as far as what are some limitations of analog and asked you some limitations of digital. When your other use cases have you run across that you find that this technology is better use?
Yeah, when you think of remodeling, we're often limited in remodels by access. So think of cranes that exist during new construction aren't there during remodels usually. So our ability to get concrete in a freight elevator and use a freight elevator to do, in this case, barbecue stations or column wraps or interior facade walls, because our units are 1/6 the weight of precast on a comparable constructability, we're able to get a lot of units into remodels and rebuilds, repositioning projects that you wouldn't otherwise be able to do.
Yeah. So because of the you're able to print these in multiple pieces and then you put them together once you get it to the location. Is that what you're?
That's right.
Yeah. And then they're much lighter than standard precast mix or concrete mix. So you're able to move them around. The last time we spoke, we were, I don't know if we said it on the podcast, but we were discussing actually creating Formwork with the digital side of things and then filling that up with your standard concrete mix. Is there any developments there since we spoke?
A great question. Our founder thought that getting into vertical work and doing columns as a leave-in-place form could present an opportunity. Looked at one of our challenges certainly is the shape that our formwork can be in and still achieve loads, right? Because a liquid head exerts a lot of pressure. And so what we identified in short was that circular formwork is a must-have, at least today, and in doing this at all. The marketplace for circular forms or organic forms, I don't think exists at all. It will only be produced by taking it to specifiers. And so because we remain very focused on architectural concrete for landscapes and interiors, but not yet structures, I see it as a whole separate decision maker and influencer. I do think there's a use case, Seth, for some high-end lobbies, some high-end retail spaces that could use, say, a candy cane twisted column that's actually structural, leave-in-place concrete. It's a whole separate business that we are not pursuing right now.
Gotcha.
But it's possible.
Yeah.
So if you have any listeners that want a candy cane shaped column, it would have to drop into our lap kind of thing. We're not pursuing it today.
Yeah, I gotcha. Or it sounds like a round column possibly could work.
That's right. And most columns, I mean, none of us would be surprised that designers and specifiers are very efficient to design within the limitations of what they know. And today, most of them don't know about 3D concrete print. And so they're designing to squares, they're designing to rectangles and hard edge shapes that happen to come to existence because of boards and aluminum forms. And that's what they know, right? And so that's why columns look that way.
Yeah. Yeah, so there we go. We stumbled across a limitation.
Yeah.
Anything?
So if you want to do a square, the most efficient way to do a square or rectangular column is with the technology we're used to using in SAFE. That's the place.
I think we established in that the first episode you did with us that if you're just doing, your standard structural elements in a building, to me, it doesn't make sense. And I think you agreed. Still agree. with the line of work you do. So you're looking for a unique architectural feature that is not necessarily a structural element of the building that architect wants to scribble out. Sounds like he's got almost unlimited ways and angles that he can or she can do or draw up and send it to you, and you can make it happen.
Yes.
Yeah. All right. Well, what else do we want to? Anything else when you're talking to architects about analog versus digital formwork that comes up that you want to cover today before we take off?
Yeah, I would say that one of the interesting things about working in digital formwork is that it coordinates well with other materials. We have a project right now that is literally printing today that's integrating with millwork. So imagine an interior lobby. You come into a remodel in Austin, Texas for a headquarters, and they have this desk that starts at typical desk height that it morphs and shifts down to ADA height and then continues to morph and shift and becomes a wrap around the main staircase, comes to the other side of the staircase and becomes a planter wall. And all of this is integrated with millwork. And when you think about integrating these kind of materials, they're building in their factory this millwork. We're building in our factory all of this concrete. And it's all coming together in a job site and marrying up in very precise ways. I think the collaboration of digital formwork certainly lends itself to these kind of opportunities.
Yeah. So that's like a reception area. Is that what you're describing?
It is. Yeah, it's a security, and then they do some package shipping and receiving stuff, as well as a main entrance that goes up the staircase.
Yeah.
It's definitely a sculptural feature to the main entrance.
Yeah. Well, I follow you on LinkedIn, and you always post. I mean, that's what I think of when I see your stuff. Is it's very artistic most of the time.
Right.
So, all right. Well,
yeah,
I'm glad we got caught up. Sounds like things are still going in the direction that you and I discussed a couple years back, and finding the right projects to spend your time on. But if folks want to reach out to you, Darren, and learn more about PIKUS, what's the best way?
Yeah, best way is to just ping me, Darren, at PIKUS3D.com, or direct message me on LinkedIn. Those would be the two best ways to reach me. If you have a project that's brewing, or if you have further questions about how you use digital formwork to design whatever you want in concrete, you can reach me there.
Yeah. It's a different way of thinking.
Yeah.
All right, Darren. Well, I appreciate you coming on the show today. Yes, sir. And folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, working hard to get